The thing about NASA archives is sometimes you go in looking for one thing and you find some total other gem that you weren't expecting. Case in point, I found this picture of 3 women in what are unmistakably Apollo spacesuits. So I wanted to know why. So I found out. The story of these women in their Apollo-era suits is actually the story of Spacelab. So let's go back a little bit and talk about what NASA did after the moon landing. Not exactly from the moment that it was created, but pretty early on in its existence, NASA's singular focus was putting a man on the moon and returning him safely to the Earth by the end of the decade. This was President Kennedy's challenge to NASA and America in 1961, and as we know, it was the challenge realized with the Apollo 11 mission in 1969. Originally, there were supposed to be missions through Apollo 20, which would mean 10 landed missions on the moon. But as the program's budget was cut back and back and back towards the end of the 1960s, we lost the last 3 Apollo missions. So NASA had to figure out what it was going to do next. There was a question of maybe we repurpose the hardware and do some deep space missions like to Mars and Venus. There were actually proposals for human flyby missions of Mars, of Venus, and of both, which I think would be a super cool mission. There was also, of course, talk of a space station. This was something that people like Wernher von Braun and other early space pioneers had been talking about since the 1940s and 1950s. A space station would not only teach us a lot about living and working in space, it could serve as the launch point for missions to Mars, to the moon, and beyond. So NASA decided to look into this idea of a space station. Now, one of the iterations of this, as we know, was Skylab, NASA's first space station that only saw 3 crews visit it. Another thing that came from these early discussions of a space station was Spacelab. Spacelab was a joint program between the European Space Agency and NASA. In the case of NASA, it was managed by the Marshall Space Flight Center in Alabama. As the name suggests, this was a space-based laboratory designed to fly in the cargo bay of the Space Shuttle orbiter and would allow scientists who were not astronauts to send their experiments up into orbit. The lab developed into something the size of a trailer, making it large enough to house a significant science payload while still fitting in the cargo bay. Part of the lab was an enclosed, pressurized section that would give the astronauts a shirt-sleeves environment, and the other half was a series of open, U-shaped pallets where experiments, telescopes, and other kinds of sensors could be mounted and exposed to space. Building this lab was a different kind of challenge for NASA. To this point, each one of its spacecraft had been custom built for a specific mission, and crew comfort kind of went by the wayside as a result. It was all great to go to the moon, but you go to the moon and you have to poop in a bag. So now NASA was starting to really consider human factors, because shuttle missions wouldn't be 2-week-long trips with the singular goal of getting to the moon. Now they could be weeks or maybe even months-long missions that would need astronauts to be happy and healthy in orbit for a really long time. In an attempt to marry the need for human factors and good working conditions with the practicality of a laboratory in space, NASA built a mock lab where scientists could figure out how best to arrange things in the actual space lab. This begat the General Purpose Laboratory as part of the Concept Verification Test, and it was effectively an analog of Spacelab that scientists could work in on Earth. Among those scientists were principal investigators of 11 experiments that were feeding into the development of Spacelab. These are our women in Apollo suits. First, we have Ann Whitaker, a physicist with a master's degree in solid-state physics. She'd been working with NASA for years, focusing on lubrication and space physics, as well as semiconductor and solar cells. Next, we have Dr. Mary Helen Johnson, a NASA Marshall metallurgist. She was most excited about Spacelab because it offered scientists a unique way to work with new and unique metals in space. Carolyn Greiner was an astronautical engineer who also in her earlier work worked with sounding rockets. This taught her that some material processing can only be done in a weightless environment or in low gravity, and thus saw Spacelab as a way to investigate and develop materials that could have life-changing effects on Earth. Another woman listed as part of this test but not pictured is another engineer named Doris Chandler. In the early 1970s, these 4 women were part of a very small female contingent working at NASA Marshall, just 42 women, or 2% of the total workforce. So when 4 of them became a crew for a simulated mission, it was kind of a big deal. For 5 days in December of 1974, they spent 8 to 12 hours a day working on their individual experiments in the General Purpose Laboratory. Though the mission was a simulation, the experiments were real, as were the working conditions. The air circulation, temperature, humidity, and all environmental factors were controlled exactly as they would be in orbit. The lab mimicked the close conditions of space as well. Just 14 feet wide and 24 feet long, part of the experiment was actually to see how much the women bumped into each other, because of course, engineers had to make sure they built Spacelab with a good workflow. The crew's post-test report highlighted the importance of keeping the workspace clean and everyone working together, and it also stressed the need for the astronauts running experiments in space to be expertly trained. On the second day of the test, the women nearly lost 2 experiments, but they were able to save it because they knew the science so well and also understood their workstations. They figured if it was important for astronauts to have specialized training to run experiments in space, wouldn't it be better to just send the scientists themselves? And weren't they 4 very capable scientists who might not want to go into space? Well, they knew that NASA was looking to expand the astronaut corps with mission specialists and scientists, not just pilots, and that opened the door for women. And so in 1974, they all started specialized training to increase their chances of actually flying in space. They began with dry testing, wearing bulky pressure suits in high-altitude chambers to see how the bulky garment would affect their mobility and dexterity while working. Then it was on to wet training. They took scuba lessons to get used to working underwater before diving in full pressure suits in NASA's Neutral Buoyancy Lab. They even trained in the KC-135, the so-called vomit comet, that flies in parabolas. This gave them brief moments of weightlessness so they would have a taste of what it would be like to work in the real space lab. They even took flying lessons. When NASA accepted its first women into the astronaut corps in 1978, neither Anne, Mary, nor Carolyn were among their ranks, though Carolyn had made it as a finalist. Anne was shortlisted to serve as a mission specialist on a Spacelab flight but never flew. Mary, too, was assigned a backup mission specialist for a Spacelab mission, but never went into space. The 3 women, however, did have stunning NASA careers. As for Spacelab, it taught NASA a lot about how scientists need to work in space. One of the really interesting things that came out of the Spacelab program was cassette-like modules for experiments. It's something NASA astronauts still use on the ISS today. Spacelab also taught international partners how to work together on long-term goals, and taught crews how to pick up where one leaves off when they overlap on a station, which might sound familiar because that's what astronauts do on the ISS today. Spacelab components flew on 22 NASA missions between 1983 and 1998, at which point construction began on the International Space Station. And much like Spacelab has informed the ISS's design and how humans live up there, the ISS will undoubtedly inform the next generation of space station. My blog is now over at Medium, so if you would like to know a little bit more about this story and about the women, be sure to check out my companion piece. The link is in the description below. And if you have other questions about anything related, please leave them in the comments. I also want to remind you guys that my brand new book, Fighting for Space, which is all about women vying to be astronauts in the 1960s, comes out on February 18th, 2020. You can pre-order now. I've got all the links that you need down in the description below.